with this one, my buds. Okay, we talked yesterday about table 310.15b16, the derating, and all this good stuff. So that was part of our what we did yesterday, if you guys remember. We talked about a bunch of other things. Conductors. We talked about the conductors are measured in AWGs, right? And KCM. We went to 310.15. We did the ampacity based on 30 degrees. Everybody's okay with going to 310.15b16, finding the ampacity based on the rules of the 60, 70, and 90. That's very, very important, what we did yesterday. There's a couple of things I would like to mention here, guys. We use the circular mill in the USA, right? We use the circular mill a lot. And I don't know how many of you know that one. It's really nice just to know, FYI. A circular mill is actually, a mill is 1/1000th of an inch. So a circular mill, if you guys want to do your math, you take the 0.001 multiplied by 0.001, and that will get you a circular mill. So Jeff, when you say 500 kcm, 500,000 circular mill, you're looking at 500,000 0.001 times 0.001. Like a cross-sectional area, unlike the metric system where they use centimeters squared, they take the area, the cross-sectional area of the conductor. So this is just FYI, guys. This would be equivalent to the area, but not really the area of the conductor. Equivalent to the area, but not really the area of the conductor. So, so that's where your circular mill here, circular mill equal, take these two numbers, and then this will transfer into KCM. KCM, obviously, it's 1,000 circular mill. So you do your math. Everybody knows that a mill is 0.1/1000 of an inch. You circular, you multiply by itself, get you this number, and then multiply it by 1,000, will get you the KCM that we use all the time. So that's just FYI. We talked yesterday, guys, about conductors must be protected against overcurrent protection, against overcurrent with a fuse or a circuit breaker, and the codes say that you cannot put on a conductor more than the conductor can handle. We talked also about these, Jeremy, we talked about these very important branch circuits when it comes to residential, and we said, I'm just going to say 14 here, number 12 here, number 10 here, and number 8 here. So that we talked about these conductors, right? And these are the most common branch circuits. Any comments, guys, about these most common branch circuits when it comes to common branch circuit that we use? Any comments, any questions about that? Number 8 is going to go with this guy, and then we go number 6 with 50 if you have a 50 amp circuit breaker on it. Any comments about the most common branch circuits? The most common branch circuits. So we talked about this one. Then individual branch circuits may supply any load. If you are individual branch circuit, you can. These are supplying outlets. The only difference between individual branch circuit and these branch circuits, I can 15 amp. I can have 3, 4, 5, 6 receptacles in them, multiple loads. Individual circuit, one load per circuit. Everybody knows what an individual circuit is. One load per circuit. One load per circuit. I can have a branch circuit that's 200 amp branch circuits. Typically, these can be shared. Loads can shared up to 50 amp branch circuits. After 50 amp, they become dedicated individual branch circuits. When we talk about dwelling, guys, these are basically what our project, Jeff. It's going to be somewhere between these 3 circuits, and we identify them, or these 1, 2, basically 1, 2, 3, 4 circuits. These are all what we're going to be using for the residential project. Any comments, guys, about these? Any comments about this project? Then we talked yesterday about where we use all these, and notoriously famous, guys, a 20 amp circuit in dwelling is used. Anybody can remember where? It's 2 small appliances circuits, 1 GFCI receptacle for the bathroom, 1 for the laundry. There's 4 of them required by code. 2 in the kitchen, 1 in the bathroom, 1 in the laundry. Done. These are required. Now, recommended, strongly recommended, you have a garbage disposal and a dishwasher one per each. If you have a sump pump, of course, also required that you have sump pump 20 amp circuits. What else that could be 20 amp circuit? Garage. Yeah, put a circuit for the garage, recommended, not required. So these are your 20 amp circuit. 30 amp circuit, anybody knows where 30 amp circuit can go? These are typically dryers. You can dryers and AC. AC and dryers are your 30 circuits. 40 amp or 50 amp circuit, you are talking about cooking equipment. These are your range. Over 50 circuits typically for what? For AC and heating and cooling equipment, chillers, air handling units, and so forth. But we don't use them a whole lot in residential though. Any question, guys, about these branch circuits? Any question about these branch circuits? When we talk about dwellings, where do we use the 15 amp branch circuits, guys? We use 15 amp branch circuits only for convenient receptacles and lights. Convenient receptacle and lights. Any comments about these branch circuits? If there's anything you need to kind of stick in your mind, these branch circuits that we can use and what you can feed from them. Okay. We talked about aluminum conductor, guys, cannot be landed on anything that's not rated for aluminum. So if it's an aluminum conductor, it has to be rated for aluminum. Conductors must be protected based on overcome protection device. So, for example, if I have an overcome protection device 20 amp here, this conductor cannot be smaller than number 12, right? This is what they're saying. Conductors must be protected based on their overcome protection device. Now, there's a few things we talked about yesterday, guys. We talked the small conductor rules. Remember the small conductor rules up to number 10? And we talked about when to use 60 and 75 and use the derating. Any comments, guys, about these? Any comments? When we go commercial, we'll start talking about tabbing conductor, the rules for tabbing conductors, and it will be slightly different. So if you're doing aluminum, you have to torque a lot, extra installation procedures to prevent fires. If you're using, typically we don't use a whole lot of conductors, 14 and 12 and 10. You go feeders. 1/0 and 2/0 becomes more economical to use aluminum conductors just because they're first light, second cheap, third light and cheap for installation. So, but all what you need to do, there's procedures for installing them and the stuff that you put on them, and also torquing them is a lot more. You know, the irony is when it comes to aluminum, utilities use aluminum all the time, guys. But the crimp-on connectors, they have crimp-on connectors that sits there forever, and it's functioning really cool. The only difference between them and us is they are out most of the time. They're all outside on the poles, so if it arcs and sparks, not a big deal. Connectors, we'll look at a couple of connectors here. I know you guys are not electricians, but if you become the project manager, these are really cool to look at. So these are the wire knots. You can get them up to number, what is it, number 6, I believe, if you read through that one. You can get these boys up to number 6. Wire knots, a lot of you are familiar with the wire knots. So you have, no? What? Really? Wire knots? So the wire knots. And the other things, guys, the notoriously famous wire knots are easy, but I don't know how many of you guys are familiar with the crimp ones. This is, you can get this one up to 500 kcl. Typically, the cheapest way to use these, the wire nuts is easy. You see them in the box. But these one, if you have a gutter, and if you bring a feeder and you want to tab from this feeder to feed multiple things, so that will be a good application for this crimp connectors, where you tab a 500 conductor into a 500 kcm conductor, tab from it 250 kcm conductor to go to a different panel. So this is the tabbing rule, really cool. So here's a conductor and you're tabbing with these. This is a great way of tabbing. There is my 500 kcm again, and this is my 250 kcm. Tabbing using this type of connectors. There's a bunch of other connectors that you can use here too. Lugs, typically for panels, you can get them up to 500, the same thing, 500 kcm. Split bolt tool is another way of tapping. All these ones that I highlighted, this one and this one, if you talk about major equipment, guys, these are used typically for major equipment for the most part. The split bolt, the clamp, the lugs, of course, you can use them also in the smaller equipment. So these are different ways of termination. Unless you're a project manager, it's really FYI. Electricians, we use them all the time. But unless you're a project manager, most of the branch circuit is going to be with the twisted wire nuts. As I said, you can go only when you tap feeders. You're going to be getting into the split bolt as well as the clamp. Any comments about these? We're designers, so this is probably most of it is FYI. Compression connectors, these are great for a lot of application. If you can see 1000 kcm, so you crimp that one on one end of the cable, and from the other end you land it on the lug of that feeder, and you torque them. Any comments, guys? Any questions about these connectors and wire nuts? These really, for the most part, being designers is FYI. Okay, we'll look at table. There's one table here I want to look at, guys. This is the table that lists all the conductors. The notoriously famous conductor that we use is THHN/THW. That's the most common conductor, THHN/THW. Now we're coming to commercial. We'll talk about this when we go to commercial too. We're still residential. The stuff that we use in residential is N M cable. Almost all the stuff that we'll be using in M cable. And M cable is made out of THHN conductors inside it. NMB, absolutely. NMB. NM cable, NMB. Most common, we'll talk about NMB and the other application in C and S. So that's basically what this table, the most important one that you guys are going to be looking at is this type of insulation. There's TW and a bunch of other ones. When we use a conductor, guys, you have to understand the cable or the conductor have to be rated for a wet or dry or damp location. Typically, dry location is easy. Every conductor almost is rated for a dry location, give or take. The problem becomes with damp, especially with wet location. So if the conductor, how would I know if this conductor is rated for wet location? We're going to go to the table, this table, and this table, 310.104A, it will tell you if the conductor is rated for wet or damp location. For example, THHN conductor, 90-degree temperature, rated for dry location. Every time you see a W, stands for what? Wet location. So these are, a lot of it is a quick review for you. So dry and damp location, temperature rating, listed for more than one application. There's a lot of conductors, guys, and we go through this one as we move on. Okay, circuit have several components that each has a temperature rating. This is probably one of the most important things that you have to understand when it comes to temperature rating. Let me just draw a little log here and grab the circuit breaker here, and here's my log. This is inside the panel. This is my busway here inside the panel. Here's my log, and then here's my cable, here's my log again, and here's my equipment. So what they're saying, guys, each one of these has a temperature. So there is a temperature here, a temperature for conductor, a temperature for lug, a temperature for the equipment, a temperature for the panel. Each one of these equipment has a temperature rating. And when we design a system, Brian, you are not to exceed the lowest temperature rating on the system. That's all. So for example, if the panel, let's just say the panel is rated for 75 degrees Celsius, this lug is 60 degrees Celsius, this conductor is 90 degrees Celsius, this lug here is 90 degrees Celsius. I have a lug rated 90 degree, a conductor rated 90 degree, another lug on the other end of the cable rated 60, and the panel rated 75. Which one do you think when we size conductors, we're going to size based on which one? The weakest link. Everybody knows that? The weakest link. Called the weakest link. Here's my weakest link in this case. So if you don't know, you guys remember I wrote yesterday, if you don't know what the lugs are, the divider is 100 or more. 100 or less, 60, more than 100, by default is 75 for lugs. Cables is easy. You know, if based on the installation THHN will be 90 and so forth. These are all temperature rating. The weakest link, that's where you always size based on the weakest link. Always the weakest link in all these temperature ratings. Everybody got that one? The weakest link in terms of temperature rating of all these things. You choose the one that has the lowest temperature and you size the amp to be carried as the weakest link. A lot of you guys don't understand. Also, if I put a conduit here, if you got a PVC conduit, I have a PVC conduit, and this conduit is rated for 90 degrees also. Now I can't exceed the temperature rating of this conduit. You don't get into a whole lot of troubles if you're doing low voltage. If you do a high voltage, like medium voltage system, and you're sizing your conductor based on 105, you're sizing your conductor based on 105 and your conduits cannot handle, it's a PVC conduit rated for 90, then you have to limit the conductor to 90 because of the conduit. Typically non-metallic conduits like PVC becomes also have a rating, temperature rating. If it's steel conduit, not a big deal. Okay, nub and tube. You guys are not going to be, this is FYI, if you're doing in an apartment building or a house and doing remodeling, you understand that nub and tube in the past they used to splice. Anybody have wired nub and tube? They splice no junction boxes. No junction boxes, so you have to be aware of that one. A lot of application is you mess with a nub and tube, you basically change the whole wall. So
yeah, they say tap Romex off of old nub and tube.
You can tab Romex.
Well, no, they T-tap Romex off of old nub and tube.
But you have to put a gearbox though.
I'm just saying the old stuff, like what you find.
Yeah.
They would T-tap Romex just on the knob and tube.
Without the box or anything? Yeah, without the gearbox. Yeah. So the problem with, we're not electrician, but the problem with nub and tube guys is they tab them, share the neutral. So you have, if you're in a situation where you have to have arc fault circuit interrupters, the neutral is shared, or GFs are shared, keep tripping. And of course, when they tab without the gearbox for most of the application, and that's a violation of the code. Every time you tab or terminate a conductor, we have to have a gearbox. So just FYI, neutral sizes, I promise you we're going to do a lot of calculation based on the sizing the neutral. There's a couple of things about neutral sizes, not for branch circuits, but for feeders. Neutral sizes for feeders, guys. The code says if you have a feeder. Now we're talking about feeders. We'll do that in a commercial, industrial. A lot of these when you use them, but you have to understand that the neutral of a three-phase system always carry the unbalance between the three-phase system. If your system is heavily inharmonic, like electronics, the whole derating business is out of the picture. 61 will tell you a couple of things. For example, up to you can derate. It has to carry the unbalance, but anything higher than 200 amps on your neutral, you still can you can derate. Anything higher than 200 amps, you can have 70% derating on your neutral. I'm not going to go there yet because we're going to be doing neutral derating, guys, in details for the commercial industrial project. Just be aware your neutral conductor can be smaller than, and will be smaller than your ungrounded conductors, because it carries the unbalanced current. Voltage drop. We'll talk about voltage drop, guys. I have a couple of examples. Voltage drop in the NDC code book is actually, believe it or not, it's an information note. So it's recommendation, not a must, even though a lot of us take it as a must, information note. There's a couple of examples about what's the problem with voltage drop, especially in residential is not a big deal, with commercial, big deal. One very good example is your light will dim, your sensors will not pick up, your machines will overheat because of voltage drop. So there is a lot of application where voltage drop is a big deal. So I'll show you later on in a couple of things, guys. I have a nicer example than that. We'll talk about the voltage drop. I'm going to skip these. Romex, NMB, like you said, NMB, NMCB, and NMSB. Most of them are NMB. Typically, the NMB is typically used in indoor. NMCB, that's rated for damp and damp locations. And NMS, I believe it's for the signals. They use them for signals. S stands for the signals. Um, Almost all the stuff that we're going to be doing indoor, dry location, is going to be here. Damp location, you're going to be here, and this is signal. Signal. We have a couple of things. Most of the time, if you're doing cooling, you're looking at most likely NMB. Wiring methods, guys. Chapter 3, and I don't want to go into the details, guys. Chapter 3 has, depending how you look at it, close to 50 ways of wiring, from rigid non-metallic into rigid metallic into flexible metallic conduit into cables. All these methods are in chapter 3. The only one we're going to talk about in the in the 6 weeks is basically Article 334, which is talk about the non-metallic sheath cable, which is commonly used in residential. There's other cables, guys, other articles that we will be talking about as we move on. Okay, since NM cable is the most notoriously famous cable, you have to get used to that boy. We'll talk about it in a second. A couple of things I want to highlight, guys, about NM cable. If you're an electrician, you know that one. If you're an electrical designer and you want to be a project manager, you must know this because you're going to be inspecting your own work. So, a couple of little rules, very simple rules, guys. When you stable, you always stable 12 inches from every metallic box and 8 inches from non-metallic boxes. That's rule number 1. For typically all cables, 12 inches is typical for all cables. Okay, when you're using non-metallic boxes, you have to reduce it down into 8 inches. So that's rule number 1. When you stable them at 4.5 feet. Where's the 4.5 feet? Intervals, right here. 4.5 feet. When you stable them at 4.5 feet intervals. That's it. That's the rules that you have to do. Stable at 4.5 feet intervals, and at 8 if it's non-metallic, 12 if it's metallic from the box. You guys are familiar with the 6 inches slack. You have to leave a slack here 6 inches from the point they enter here, and 3 inches from project outwards. If you're a designer, a lot of designers care less. If you're a project manager, this is a big information to know. Does that make sense? Everybody knows the rule 6 from the point it enters and 3 from the point projects outside the box. Cool. So these are a few rules, guys, that you have to be aware of when it comes to the installation of NM cable. So any comments, guys, about this? Comments, questions? Okay. Typically, guys, wood construction, you drill holes for NM cable and you pull them in. There's rules for holes. If you're using metallic construction, you have to protect the cable because it's non-metallic cable. So you have to protect it. So I can't emphasize, if you're using metallic construction, then make sure you have to have some type of protection for it. If you're doing wood construction, you drill the hole right through the framing and you pull your conductors right through it. A couple of things that you have to maintain if you're doing residential. A couple of things, and I'm moving a little bit fast on some of these, guys. Here's the hole that you drill, either in metal, in studs. You have to maintain 1.25 inches. Everybody knows that? 1.25 inches from the edge. You guys are familiar with that? 1.25 inches from the edge as you drill. Why? Because you don't want the sheetrockers to put their screws right through the cable. 1.25 inches you have to maintain from the edge. If you can't maintain the 1.25 inches, then the code requires you to put what? A metal plate, and they give you even the thickness of it, 1/16 thick, not just a metal plate, a special metal plate, 1/16 thick. That's all. So you're not going to go to. So either you maintain 1.25 inches from every side, or you have to put that 1/16 of an inch to protect your cables. Any comments, guys, about this? So these are just a couple of instructions. Who cares? Since you guys are designers, we teach this to our apprenticeship all the time. Who cares as a designer? You're a project manager. You're leading a project. Who told me? You guys are doing a residential project, right? So you're going to be if you're a project manager there, you would hope that you know all these rules before the inspector shows up. We don't carry tools as designers. We're not allowed to carry tools, but you're going to be the project manager there working with the foreman. So hopefully, and this is your project. Ultimately, it's your baby. Do you want the inspector to walk in and see all these violations in the code and then send another team to fix it? So that's why we a little bit we mentioned, guys, the material and the installation. So it talks about cutting grooves. If you can cut grooves, guys, in the wood, as long as again you have to maintain that 1/16 protection. If you're using metallic studs, Jeff, as you probably have done tons of them, you have to use these uh, protectors to protect the conductors because you don't want to. What do you guys use? You use MC cable and what? Yeah, a lot of people, guys, if you have metallic frame, typically you are non-dwelling, and typically you can't use an M cable, so you're pulling an MC cable or AC cable, and you don't need them. This is if you have a building that's dwelling building and the frames are metallic, then you have to have these protectors to protect the insulation. Every time the insulation is non-metallic, you need to protect it if it goes through sharp objects, right? Makes sense. So you're familiar with that one. Okay, a couple of things. Again, these are for project manager, not for anyone who's going to be a designer. You can live and die without caring about these. If you're a designer and just doing CAD and Revit and you make good money, no problem. You become a project manager, you have to be aware of a couple of things. Heating and cooling. Our interface with the heating and cooling system, guys, is a big deal. Number one, if it's the supply of the heat or cool, you cannot put anything in the supply. The thing that supply, the ducts that supply heat or cool to the location. Now, the return, if you guys did dwelling, they use the cavity sometimes, the 16-inch cavity as your return, right? They use it as return. They don't put ducts, they just use the cavity as return. In this cavity, you cannot put a box, number one, and you cannot go vertical, number two. Can I go horizontal? Yes, but you can't put a box and you can't go vertical. Can I have a thumbs up, Chad? We got that one? No box. But remember, this is the return. The supply, you can't enter the supply, period.
I think go vertical.
Well, they don't want you because they don't want you to heat these conductors. These are return, yeah. The whole idea is they don't want to heat the conductor more than necessary, you know. And another thing is, now this is your return. If you have a fire here, what you're going to be doing, you're basically pulling the fire into the furnace and spreading the fire through the whole building. There's a whole lot of fire issues that we don't want you. If you're going across, you have to, because go from point to point, you almost have to. But going up, you have alternatives, right? You can go across and then go up. So, but sometimes going across, you have to, because the only way you can go from point A to point B. Going up, you can always cross and go from other direction. So it's spread the fire, and part of it, and the other part, of course, is you don't want to expose the conductor to higher temperature than it's needed. Okay, so these are a couple of things. Installation in ducts, guys. This is really interesting. Installing extremely strict when it comes to putting the conductors in a duct. The rule is, say you have a heating duct. Can I put a conductor on it? Restriction, you could use metallic, and only if it's putting a sensor inside it. We'll talk about this with the commercial. Residential doesn't make any sense, but if you have a duct right here and you need to send a sensor, get inside the duct to get into a sensor, that's the only way you can get into the duct. But I can't use the duct, the heating duct, to pull my conductors from point A to point B. If that makes sense. And why? Why the whole spiel here? Fire safety. Fire safety. Okay. Okay. A couple of rules, guys, about boxes, about connectors for installation. If you have a metallic boxes, again, this is for the project managers only. If you have a metallic box, every cable have to land under a clamp. Unless the clamp is rated for 2 cables, you have to land a clamp per cable. Clamp per cable. So that's what they're saying here. Unless they're rated for more than 1. The rest of them, guys, I'm gonna flash a couple of things and show you a couple of things about these. Basically, different type of wiring methods: rigid, intermediate, PVC, and EMT. When you guys go in the stock dwelling, So dwelling, when we talk dwelling, your NMB is your wiring. So I'm going to just dare to put 90% of what your wiring in a dwelling. It's going to be NMB here in Minnesota anyway. Now, we're talking dwelling here. Now, if you're going underground to the garage, you have two options. UF cable is the cheapest, but if I would like to go do a conduit, what would every time you go underground? So if you're going underground, your conduit of choice is always PVC. Why? Rusting. Now, if you're in a basement and the walls are not finished, you can't put NM cable in the basement without protecting it. So if you want to protect an NM cable, typically what do? We use EMP, wire non-finished walls, concrete walls. You use NMP. This is unfinished, typical, again, basement. Okay? So these are rigid and intermediate. Anybody knows where it's willing we use rigid and intermediate? Service. Service. This is for service or mast. The service mast. That's typically what you use it in dwelling. Cool? Now we're talking dwelling. When we talk commercial, when you do commercial, you just replace this one with MC cable and EMT conduit. Between MC cable and EMT conduit, you cover 90% of what you need for a commercial building. We're not commercial yet. For residential, 90% you're going to use an NM raw mix cable, and the rest of them, the 10%, an EMT conduit, typically unfinished basement, you put them in an EMT conduit. Rigid is for the service, and PVC if you're going underground, and there's other alternative for underground, like UF cable is typically what we use. Jeff, did I miss anything? Darren, anybody? So these are typically what we do, typically, again. There's nothing prevent you from wiring your house with rigid, if you so decided.
There's USE too, from your end.
USE, yep. USE 2, that's another option for underground. Flexible connection. When we talk about wiring methods, guys, here's how they divide the wiring methods. Really cool. You either have flexible conduits. There's definition when you talk about the whole wiring methods. It starts from here. If you want to talk about wiring methods. Division number 1, flexible. And the other one is non-flexible. And division number 2 for each one of them would be metallic, non-metallic, and also here we'll have metallic and non-metallic or non-metallic. So you start with the flexible, your flexible metallic conduit, or flexible non-metallic conduit. Or you go non-flexible, that's your rigid and EMP. The non-flexible can be metallic or non-metallic. So first, flexible, are you going flexible, non-flexible? 99% of the time, we go non-flexible when we do conduits. We do conduits non-flexible. When do we use the flexible, guys? Typically in dwelling, well, in anything, to tie to equipment. You tie to equipment. It absorbs vibration and make it easier for us to move the equipment. Absorb vibration and equipment. So these are, you start with first, so 90, I can dare to say when you do commercial, is probably 90% of your wiring method is non-flexible. You're talking about EMT, rigid metal conduit, and also PVC. This is in this area, metallic, PVC. These are the notoriously famous non-flexible, right? And then you go to flexible metallic conduit. This will be metallic and liquid tight flexible metallic conduit. These are the most notoriously famous two that we use. There's also flexible non-metallic conduit here. These are the notoriously famous when it comes to the wiring methods. Where would you use this one? The flexibility is only to tie to equipment. In dwelling, sometimes we fish them. We use a flexible metallic conduit to fish through the wall to go to from point A to point B. It gives you the ability to pull conductors through it and fish it easily. I can't emphasize that this is one of the most, if you guys want to remember one thing, transfer of vibration. The reason why we don't rigid the air handling unit directly to the air handling unit and we flex it, because we don't want, you put rigid to a machine that vibrates, the whole building the whole EMP structure is going to be vibrating. So you want to avoid that one. Electrical non-metallic tubing. There's for metallic, there's the notoriously famous, of course, PVC, and there's also electrical non-metallic tubing. Application is barns. They use a lot of barns. They use them because of highly corrosive environment. If you have a highly corrosive environment, this is what they call it: ear, nose, and throat doctor. The ear, nose, and throat doctor, right? ENT doctor, ear, nose, and throat doctor. This one is in highly corrosive environment. It's blue, it's flexible, it's non-metallic. If you have a highly corrosive environment, guys, you wouldn't use anything metallic. And we know why, because it rusts like crazy. Barns is notoriously famous of these locations, or any place where it's highly corrosive. Again, PVC will get you there too, but the advantage, this is the alternative, this is using a PVC, but the advantage of this, it's flexible, more flexible, it's pliable, more flexible than the PVC. That's its wire methods. I don't see where we can use it residential. I've never seen it in residential. ENT, anybody? I've seen it in dwellings. Typically, another application for it, it's if you have a lab that you don't want interference, so you don't want to use metallic because of interference. Non-flexible doesn't act like an antenna, right? So, and you need flexibility, pliability, and non-metallic because of interference. Labs, for example, sensitive electronic labs is a good example of that.
Or be in a place where they wash down stuff, frequently.
Yeah, wash down stuff
Like,
frequently. Food processing places, absolutely. PVC and EMT becomes a big deal. So these are another option for you for wiring methods. Service cables, guys. We'll talk about this one. Show you a couple of things in service cables. Service cables typically bringing power to the building. Sometimes we use them for branch circuits, for major equipment like ranges or dryers. But typically these are the cables that two cables twisted that coming to your building. That's the main application. If you have a multi-building, like in a that would be a farm. If you live in a farm and you have a pole in the middle of a yard, and you take a brand that will be service conductor to each one of these structures, an SC cable would be your cable of choice in these applications. I wouldn't wire the whole house with an SC cable. It wouldn't be economical, though you can. That's basically a few things about SC cables. To do your meters. Okay, I have a couple of pictures I want to show you guys, and then we'll let you run. All right, we talked about branch circuits. I know, Jeff, you and I talked about this one. Here's a typical branch circuit non-continuous. Now, you wouldn't do that. In a non-continuous branch circuit, guys, if you put an overcap protection device here, 20 amp, and a number 12 here, this is a typical non-continuous branch circuit. 5, 5, 5, 5, add up to 20, non-continuous. Had this, you wouldn't do that though. You wouldn't do that. Now, had this been a continuous load, what do? You knock that 20 amp, the load-wise, you take 80%, 20 times 20 will get you up 16. Divide the 16 by, I have 4 loads here, by 4 to see how much each load will be. They'll give you 4 amps. So you're going to knock these 4, 4, 4, 4. Same circuit. If it's continuous, you're limited to 4 amps each lamp. If it's non-continuous, you can pull the 10 amps, the whole 5 amps. Any questions about this? Does it make sense, Jamie? So that's I thought that's a nice graphic to do that. This is what they talk about, guys. 20 amp circuit. Receptacles are non-continuous, so you can pull your receptacles from a J box. We talked about this one yesterday, and we talked about the rating of the circuit. This is just very quick review, right? Everybody knows that the rating of the circuit is the rating of the overcap protection device. I want to remind you guys, overcap protection device 15, 15, 15. The cable is 15, 20, 20, and 30. All these circuits are 15 amp branch circuit. regardless of the cable. Can I have thumbs up, Chad? We got that one. So it doesn't matter what the cable is. What decides the name and the rating of the circuit, the branch circuit, is the lower current protection device ahead of it. So we talked about the logs and notoriously famous logs. When we do tours, guys, you're going to see, and I know Jeff laughed at me about the twisted wire nuts here, but you see how important these ones are when it comes right here, how important these ones when we tab conductors. These have become very, very important when you tab a 500 kcm and you need to take 4 out from it. What's the alternative, guys? You're going to be project managers. What's the alternative? Why wouldn't I use, now engineers don't like the tab. Tab rules, a lot of engineers don't like them. Because tabs, it's not reliable. If the feeder trips, you tripped 4 panels. What's the good thing about the tabs with these is it's cheaper installation. You have a gutter, you grab a gutter like this, and you tab a conductor, you bring a conductor here, and you tab and you disconnect here, disconnect here, disconnect here. Look at that, and you feed, and here's your 400 amp coming in here, and each one of these disconnect is 100 amp, 100 amp, 100 amp. How do you do this installation inside the gutter? That's where you use this one. You tap it right here. Each phase, of course. Each phase or each hop. That's where these becomes really handy. Does that make sense?
You saying so then the alternative to that, the more expensive would be like a CT cabinet?
Well, the alternative of this CT cabinet is more expensive. The cheaper even alternative is to have, the cheaper for this one is to have another panel. Instead of the gutter here, I would put another panel here, bring my feeder in here, and feed each one of these from a branch circuit, in this case, a feeder. So here's another piece of equipment here. You see why these becomes really interesting? These gutters, you put the connectors inside them. So it becomes really, really, you use this one as well as this, the split bolt too. These are also used as 2 ways of tabbing. Any comments, guys? Any questions about that? So that's why this one is a really cool stuff. Nub and tube. Your nub and tube, I still have to find a way of erasing these without erasing it. Here's your nub and tube. Be aware of that one. They do it like, it's interesting to see a nub and tube wiring, huh? Okay, just be aware of that. Again, you're designers, guys. We're not installers, but they tab.
Yeah, they're uninsulated cables and there's board holes, the lighting insulators.
Yeah.
So it's just bare cable that's hot running through the joints with hopefully insulated.
Yeah, and you can see that they're running them far away from. You can go the phase in one and the neutral in another one. So it's yeah. So if you're to tab from these, if you open the walls, you have to remove them. If you tab from them, you have to put a J box. But again, these are, you guys rarely will do that one. Okay, so that's a couple of things I wanted to highlight here before I go to the more important diagram, line to line, line to neutral. This is, you can't believe people come and leave and they still don't understand that you can tie. This is very important picture to show you that you can, in a single phase system, this is single phase 3-wire system. There's a lot of system, guys. Single phase 3-wire system. You can tie load to load, or you can tie load to neutral, So the most important things to understand, if I have 20 amps here and 20 amps here, so 20 amps came into this one, and I also have, out of the 20, I have 10 amps here, and this load, out of the 20, I have 9 amps here, okay? So I have another 9 amps here. So I have 10 amp, 9, 9, 10. What do you think the neutral is going to see? The neutral is going to be 1 amp. So do you think the line to line will contribute to the neutral in any way, shape, or form? No. Can you see, if you tie an equipment line to line, they don't contribute to the unbalanced neutral. Can I have thumbs up, Chad? We know line to line would not contribute to the unbalance of the neutral. Okay, so that's Voltage drop. There's a couple of pictures, guys. Really nice picture about voltage drop. Voltage drop, and I left it until the end. For voltage drop calculation, let me go back to the rule, and I want you guys to know it once and for good. Here's the rule. The rule for voltage drop that typically we use, and the recommendation, the rule is, this is very, very interesting because it shows you the rule. I want to emphasize that this is where the branch circuit is, and this is where the feeder is. Everybody can see I have a main panel or main switch that feed the sub panel. From the sub panel, I'm feeding a piece of equipment. Cool? Okay, now for the branch circuits, here's the scenario that we use all the time. For branch circuit, we use 2%. For feeders, we use typically 3%. You can do 2, 3, or 3, 2 for a total of no more than 5 together. Okay? What do engineers do typically? 3 on the feeders and 2% on the 3 on the feeders, 2% on the branch circuit. Can I have thumbs up, Chad? We understand that. 2 on the feeders. Okay, so what does that mean though? What does that mean to you? It means very simple thing. I started right here at the service, and I have a 20 amp circuit. I measure the voltage. Oh, by the way, when you measure the voltage, make sure the equipment is turned on. The equipment is running. You measure the voltage when the equipment is not running. You're measuring an open voltage, what we call it, open circuit voltage. It will give you 120 here and here because there's nothing running. Run the equipment. Measure the voltage here, give you 120. Now from this point to this point, where we measure right at the load, it's going to be right in here. I should not lose more than 5% of the 120. Okay, so take 5% of 120, give you 6 volts. So there's 6 volts I'm allowed to lose between the feeders and the branch circuit altogether. So if you take 6 minus the 120, so right at this terminal, guys, when I measure, I should get 114 volt. 114 volt. No less than 114 volt. Does that make sense why voltage drop? Why it's a big deal? If you get, say, 90 volt here, the equipment, 2 things. If it's not starting, it might not start. If it's not running, it might not start. If it's running and starting, it will be less efficient, so consume more current. And what happened with this one? If it's less efficient, consume more power, and it will also die prematurely because it pulls more current to compensate for the loss of the voltage. So that's why the code equipment, guys, almost all equipment are rated plus or minus, give or take 10%. The manufacturer of the equipment, typically they rate them plus or minus 10%. So if you give them 10% more voltage or 10% less voltage, they function. This is their kind of their range of functioning properly. You go higher than that or lower than that, they can malfunction. Now, if you guarantee that you're not going to go less than 5, then you're well within these parameters of the equipment, well within these parameters of these equipment. Cool. Everybody knows why we care about the voltage drop issues, because you want the voltage here to be 120 and the voltage right at the terminal of this light to be also 120. So that's your voltage drop on the branch circuits and feeders. Then the rest, guys, we talk about NM cable that you're familiar with. NMB, all of them are NMB cable. Couple of pictures. Jimmy, did you guys wire in our labs? Yeah. Yeah, so you did a couple of wiring with this, familiar with that. I don't know how we're going to do with the other teams. Straps, we talked about this connector. A couple of rules. The rest of them, guys, please read this chapter. The rest of them for project managers. For example, if you're coming from the floor, you're supposed to protect it up to 6 inches with a conduit, typically PVC or EMT. If you put an EMT conduit, typically we use PVC because you don't have to ground them or do anything with them. So you put the 6-inch of PVC right to protect it because people can push things and damage it. So this is for project manager again. Bringing the conductors down into the panel, you drill a hole. You caulk this hole that you have to derate. If you caulk with this hole, which you should, you have to derate. Then it gets into the derating exactly based on how many conductors. So 1, 2, 3. These are, so 3 of them. Let's say each one of them is 12 3, 12, 3, 3 of them 12, 3, and there's 3 cables. And let's just say we have the 2 hots, 6 hots in this case, and if the neutral is carrying current, depending how we wire it, it's going to be carrying the unbalanced. So at least it's going to have 6 carrying current carrying conductor in this case. So you have to do it. It's not an issue, guys, when you deal with cables. This is a couple of hardware. Again, we are not hardware guys and gals, but it's good for project managers to know that these are the stables, different type of stables that you can use with them. Jeff, this is where it tells you it's violation, putting them on the side versus putting them, standing them on the sides like this. Meets code. So can you guys do me a favor and just look at these pictures? They're really nice for project managers. Again, I know we're doing residential, but you are in the field. So cables lies flat when you put them. Moving into, this is a very nice table, especially for those of you who are sitting journeymen. They test you on it all the time. This what just tells you, can you guys see that cable here landing right underneath? The only way you can bring it down to the bottom of the rafters or the joist if the conductor is 6'2" or 8'3" or larger. 6'2" or 8'3" or larger. So what would be larger? It would be 6'3", right? 6'2" or 8'3" or larger. You can put it at the bottom. Smaller than that, you have to drill holes through. If you could not drill holes, then you have to put the running board to go from point A to point B. Any question, guys? Any questions? Why would they make a big fuss about drilling? Structural engineers don't like us to drill a lot of holes. It might be easier for us to go drill through them, but you'll be in a situation where they don't want you to drill through them, because every time you drill a hole, what happens? You compromise the structural integrity of the building. Any comments, any questions? Any comments, any questions? So this is for project managers. Grounding screws, and this is a couple of hardware that you can use for grounding screws, bunch of them. Grounding a metallic boxes, different way of grounding a metallic boxes. This is typically what we do there in a basement. This is a concrete wall. You bring your NM cable directly into an EMT conduit and you bring it to the box. You ground the box, of course, here. And they want you to strap, I think, within 12 inches right here. Within 12 inches, you have to strap your conductor within 12 inches of entering that conduit. Conduits typically within 3 feet. We support them within 3 feet of the box. Any comments, guys? Any questions? Any comments? This is typical in residential, especially unfinished basement going to an unfinished basement. Here's another way where you can bring all your cables directly to the panels. A lot of people, guys, I don't know if you Jeff, you did that. They put a board right here. A lot of people put a board here and bring them, instead of bringing them in a conduit, you bring them in a board. Yeah, a piece of plywood right there, and you bring them down. I wouldn't put a conduit, because now, in a case like this, if it's more than 24 inches, you have to derate. If it's more than 24 inches, if it's less than 24 or less, you don't derate. So if it's a little, and plus, anyway, so this is one way of bringing them better in the conduit, all these cables. But remember, if it's more than 24 inches, you have to get into the derating. Then a piece of plywood will get you there. So that's a couple of things. MC cable, a couple of AC cable, guys, and short bushings or insulation bushings are used through them. We'll talk about these cables as we go cutting through an MC cable. We talked about the distances, right? Inch and a quarter. When you bring your cables, you're supposed to bring a cable per hole, right? Everybody knows that. A cable per hole into these boxes. Strap them. So these are a couple of things, guys, you have keep in mind. We talked about this one, grooves, in order to get them in, but you have to support them with 1/16. So all these, guys, is a couple of basically application that you have. Hardwares that you can use with non-metallic and armor cables. I want to emphasize here a little bit into the conduit. When it comes to conduit, guys, typically for conduits, typically you support your conduits every 3 feet, your EMT conduit here, from the box, 3 feet from every box, and 10 feet in between. Typical, 3 feet, every 3 feet. We have rigid metal conduits at 5 feet. They allow you 5 feet if there is no support. So there's a lot of, now without getting into all the details of supporting conduits, guys, there's a whole article about supporting conduits, and especially now we're doing residential. We're not going to get into this at this moment. Flex. Here's what a good application and willing for a flex, guys. Can you guys see the flex? An ideal application for a flex is where? Tying to equipment. Garbage disposal, if it's not cord, if it's hardwired, garbage disposal, machines, anything that vibrates, that's where you use flexible metallic or non-metallic conduits. Inches, there's a couple of things. Tying, if you're outdoor, like in AC units, Jeremy, my friend, what you need to use liquid tight flexible metallic conduits, because it's obvious it's outdoor. If you're indoor, flexible metallic conduit will get you there. Outdoor, liquid tight flexible metallic conduit is your choice. So these are different sizes, guys. Permitted different, so minimum sizes. So flexible metallic conduit. Let's talk about flexible metallic conduit just for a second, guys. Flexible metallic conduit is not meant to be equipment grounding conductor. If it's there for vibration, absorb vibration, you have to pull an equipment grounding conductor with it. Flexible metallic conduit, typically you don't need it. It's qualified as an equipment grounding conductor, generally speaking, if it's used in sizes of 6 or less. Generally speaking, 6 feet or less. Typically for lighting fixtures that doesn't have vibration. But if you have a machine that vibrates, a lot of machines, then you have to pull an equipment grounding conductor through the flex or liquid tight flex, or outside, inside or outside. So that's basically where the sizes is, getting into these. This is your flexible non-metallic conduit, MC cables. This table, I'm going to emphasize a few things about this table. If you do me one little favor, I know the chapter is really big, guys, so do it one time, please. This will tell you, what I like about this table, guys, it shows you from gauge. So gauge, all these gauges here, these are control circuit. Can you guys see class 2 circuit, class 2? These are, you're going to use them for control. Can I have thumbs up, Chad? Yeah, we know control. Okay, go down. These two, these basically 4 circuit here is your branch circuit, right? Here's a 15, 50, 20, 30, 40, and 50. And it tells you what we talked about the range and the dry. So these are for your branch circuits, right? The rest of them, the last 2 guys as a branch circuit here, one is 70 and 100, and these are for electric furnace. If you have an electric furnace, typically sub panels, service conductors for a panel. So that's really nice. This sheet summarizes really all the branch circuits and the feeders that you can bring into a house. One sheet. From the branch circuit, small appliances here. So can I get you guys to look at this at least? Here's all my branch circuits typically, and these the last one are for typically sub panels and the main panel. Cords with which 2 conductors? This is I don't know how many of you guys have been there. If you have cords, they have different tables that give you different amplicity for cords. Know that one, just FYI, very few of you would be able to use it or would be using it. But this is for cords. I can't emphasize the cords. Where is the word cords? This is coming from 400.5A1 for cords. For example, if you have a cord, the cord is number 12, conductor, and cords with 3 conductors in it, how many amps can this cord carry? 20. If it's cords with 2 conductors, how many amps this cord can carry? 25. Obviously, we don't use cords for permanent wiring. We use it to tie to equipment. This becomes very handy for commercial project, guys, when you have a cord and you tie from a bus duct into a machine. We use them a lot. see any use for them in dwelling. 14 and 20 and 10. Remember we talked about the small conductor cable. Here's 14, 20, and 10, which goes with 15, 20, and 30. Copper and copper aluminum. Please look at these. If this is another nice table that tells you, can you land an aluminum conductor on a log or not? So look at the log. If a log says COALR, says aluminum, cover, clad aluminum, not together though. If it says none, nothing on it, then cover only or cover clad aluminum. If it's ALCU, then you can put cover or aluminum. So just keep an eye on these wire nuts. For example, here's wire connectors. It says CCCU or CU. So this is for cover clad aluminum only, cover only. Can you guys see all these cover only? So in order to have a wire nut that can get you aluminum, you almost have to have the AL in order to do a wire nut that can get you cover or aluminum. So any comments, any questions? Typically brand circuits residential, we're all using copper. So this is a nice table that you can use. We talked about this one, guys, yesterday too. This is 310.15B 16, 310.15B 16. We have cover conductors, aluminum, and service for each. So this is the residential. Remember how we went through this one, residential, and we sized. I'm going to go size one little thing from this table. This is 310.15B something. Let's say so we have cover conductors and the service that can goes with it. So I have a 100 amp goes with number 4, right? And they're just living it. If I have a 400 amp service, I'm going to use aluminum. That will be 600 kcm. Special table for residential. Special table for residential. Any comments, guys, about this? We looked at this one in the code yesterday. Special table. Okay, I'm going to give you 5 minutes because I really want your attention on the couple of cables. Shall we have 5 minutes? Just stretch a little bit. This is very important, guys. It has a lot of information on that table. All right. In your book, I just want to make sure that you know a few things about it, and then I'll move on. Number one, I want you guys, this table is coming from the code. It identify all the insulation that we use. For example, THHN is rated for 90 degree. That's why the rate based on 90 degree. It's in a damp or dry location, no problem. And it comes in these sizes, and this is the type of the insulation and the cover that they come up with. Can I have thumbs up, Chad? We know how to use this table. Everybody, that's directly from the code 310.104A, I believe. So that's where when we were derating yesterday, Jeremy, we were using 90. So drive down. Let's use, so if you're, this is for indoor. What if I am an outdoor? I want to use a conductor outdoor. I have to have something that has a W in it, so that would be THHW. This boy, look at this boy. This is rated, if you're outdoor, it's 75. If you're indoor, it's 90 degrees. The same thing, you can buy this baby from 14 to 1,000 kcm. Cool? So these are basically the most notoriously famous ones that you will be encountering. If you have a UF cable, remember that UF, since we're doing underground feeder or branch circuit cable, this is rated for 60 degrees. So for the most part, and these are only the sizes that you can get them through, up to 4/0. After that, you have to move to a different wiring methods. So typically we use them for 40 degrees, 60 degrees for sizing. Any comments, guys, about these? The most notoriously famous, you're going to be using commercial industrial, these two. This comes also handy here. THW and -2, rated for 90 degree wet or damp location. Any comments about this table, identifying the insulation? Comments about this table, identifying the insulation? We talk about the temperature rating for lugs and terminal rating and so forth yesterday. And this is basically telling you that you have to use the weakest link. If the lug's temperature is smaller than the cable temperature, that's what you have to use. This table, guys, gives you, this is table 8 in chapter 9 in NEC code book. So for example, when you do voltage drop calculation, and you need the circular mill of number one odd. Here's the circular mill. No rocket science. This is coming from chapter number 9, table number 8, which we will be using for voltage drop when we do voltage drop calculation. So that's directly coming from the circular mill. Comments, questions about that one? Everybody guys understand that? Where it's coming from? You don't want to go that one. This is summarizes the uses for NM cable. I thought that's really interesting. The uses for NM cable. And without getting into all details, let me just say maybe use as a service conductor. Look at this. I'm going to highlight this one. Can I use an NM cable, NMB cable, actually an NMB and NMC and NMS, all these 3 types? Can I use them as service? Can you guys see where you cannot? This is not a service entrance conductor cable. Can you see that? You can't use them as service entrance conductor. So that's what I want to highlight, the most important one. How about in walls, masonry, and blocks? So that's a damn location. Walls, masonry, and blocks. Which one of them is, all of them can be used? How about in an outside wall damn location? Masonry blocks. Which one of them can be used in an outside wall for damn location? The C. So anyway, these 3 types, this one, guys, is the we're going to be wiring inside. This one is for damp location. This one is signals, has signal wire in it. That's for signal. So this kind of summarize where you can use them. Here's my favorite one right in here. Has fungus resistance and corrosion resistance outer covering, right? Which one of them has that? That guy, right? See where the difference? That's the only difference between type NMC and type NM, basically. Make sense? So you can use it, all these. Okay, where can I use them in concrete masonry, embedded in concrete masonry? The same thing. These are no. All these are no. Any question, guys? And the limitation also 600 volt. Can I use it for higher than 600 volt? No. So this table will give you these limitations of this NM cable. Any comments, any questions about this? This one is typically replaced by UF cable. Think of this part as like a UF cable. Good for underground burial, so that's kind of equivalent. Okay, so that's what I wanted to mention here. Equipment grounding conductor. We will talk about grounding and bonding, and you're going to get sick of this table. For the time being, if you know it now, you got it, and you're done with it. Equipment grounding conductor, guys, typically come with the cable, the same size for the most part. I want to highlight a few things for the equipment grounding conductor. Like I said, guys, in order for the circuit to work, you need a hot. To work efficiently, you need a neutral. To work efficiently, and safe, what do you need? A ground. So that's where the ground becomes a big deal. I will remind you for the 15 amp, 14, 20, 12, 30, 10. So up to this point, they really match the branch circuit. Can you guys see that? They really match the branch circuit. So up to 15 to 30, they match the branch circuit. So your branch circuit is 30, is number 10. Your ground is number 10. After 40, they start getting a little bit lower than the branch circuit, right? Right? So I want to just emphasize that one. So if I have a 200 amp, the equipment, the grounding conductor for a 200 amp sub panel is number 6 cover. Okay? Any comments, guys, about the equipment grounding conductor? We will talk. Everybody knows what the equipment grounding conductor is? This is not the service. This is not the bonding. This is the conductor that goes to ground the equipment, the frame of the equipment. The frame of the equipment. Example. So if I have a machine here, and my machine, I'm going to go tie this machine 240. Okay, this is a 40 amp machine. Here's my conductor. For 40 amp machine, what do I need? These have to be number 8, right? From the code, 2 conductors, number 8. Now I need to pull a ground with it. Jeremy, my friend. Here's my ground. It's no hots. So what do you guys think the ground is going to be? Look at the overcompression device. It's 40. The overcurrent protection device is 40. What do you guys think that based on 40? What would the equivalent grounded conductor be? Number 10. Number 10. That's it. AWG. This is AWG. So a machine that protected by 40 amps and the branch circuit conductor is number 8. Going for it. We'll take a number 6 as an equivalent grounded conductor. Any comments, any questions about this, the equivalent grounded conductor? So that's what I wanted to mention. The rest of them, guys, they're going in details, and I can bore you with these, but I really would like you to look at them. Most of the stuff we're not going to be doing here, but it will become very handy as we move through the year. So if I can just get you to look at these, please, if you can go to that table and look at a few things I want to highlight. I think, Jeff, my friend, what they did is they summarized almost what? Like 9 wiring methods in a couple of tables. 9 wiring methods, a lot of information. So if it's a lot of information, it is. Okay, so we're not using MC cable, but they have an MC cable. Compare the MC cable to NM cable, guys. Can you guys go to table, please? Can you go to table 4.12? These are the 2 articles about, and let me tell you about MC cable. When we go commercial engineering project, guys, we're using EMT MC cable done. Okay. So look at the advantage. My main advantage of EMC. So number of conductors, you can have them 2 to 4 carrying conductors. Number of carrying conductors, at least 1 manufacturer that has home runs. So you can have a lot of conductors. Look at the sizes. Can you guys see, Darren? Can you see the difference between MC cable and AC cable in terms of sizes? Can you guys see that MC cable can go up to 2,000 kcm versus AC cable is only limited to number 1? Make sense? So that's where color coding, you have black, white. They have the black, white, red, and different color coding. Equivalent grounded conductor, each one of them have. Bonding and grounding conductor. Bonding and grounding in MC cable have its own insulated grounding conductor. The insulation they have, both of them have 90 degree insulation, and we size them based on 75. The AC cable. So that's the armor that they use, description of the armor that they use. So that's what I just want to show, that comparing the 2 sizes. I want to just blow up here the 2,000 kcm, where MC cable can be a bigger cable and bigger size. Moving on, guys, where can you use them? You can use them in service or branch circuit, no problem. Jeff, look what the disadvantage of AC cable. Can I use it as a service? No. Again, this is a lot of information, guys, taking it from a lot of sources in NEC code book. You have to go to all these tables and articles to get them. So it's really one table, summarize all this stuff for you. Dry and wet location. Can I use them in a dry location? Yes. Can I use them in wet location? Not AC. MC, though, they have a cable that's rated for wet location. As a matter of fact, they have a cable that's rated for direct burial, too. You can bury it. So that's where MC becomes superior. Can I get you guys to understand MC is superior when it comes to commercial industrial? Only probably residential, if any. But MC is, but it's a wiring method. In any raceway, you can use AC, but you can use MC. So anyway, direct burial, yep, you can only use MC that's identified for direct burial, but they don't identify AC for direct burial. Anyway, can I just get you that these tables comparing 2 very important cables? For this, at this time, guys, we're doing residential, so it doesn't mean a whole lot. So please keep these in mind as we move into the commercial project, because that's what we're going to be using, MC cable. Cool? Can I have a thumbs up that we got that one, Chad? So I know there's a lot of information, so on these. All right, the next table, guys, is summarizing the, okay, we talked about conduits. This is, look how many conduits. We have 3 metallic conduits and 1 non-metallic conduits. All of them are non-flexible. So I have the rigid, intermediate, rigid, and PVC and EMT. Between EMT and MC cable, you will cover 90% of your commercial wiring. Cool. In residential, doesn't mean a whole lot. So it talks about bends. Can you guys see about bends? You can't bend conduit more than 360 degrees. We all learned that. So you can make a circle out of the conduit. After you make the first circle, you have to put a J box. Okay, you can pull a conductor more than 360 degrees. Bending radius, there's minimum bending radius, guys, in chapter 9. Bushings, this is really interesting. Bushings, you have to provide a bushings for anything number 4 or larger. When you put a conductor, Jeff, as you know, conductor number 4 or larger in a conduit, and you pull them, you're going to damage the insulation. So they have a bushing, plastic bushing that you put there to protect the insulation. So look where it's required, number 4, number 4, number 4. If you have EMT, also number 4 for the most part. Typically number 4. The only place where you have it for everyone, if you have a threaded rigid, then you put them for all of them. Cable permitted inside it, almost all of them are yes. Cinder fill, can you put them in cinder fill? Almost some are yes, with some exceptions. Concealed in walls, bring it on. Concrete above ground, bring it on. Steel, yes. Aluminum, though rigid, EMT, you don't put the aluminum EMT here. There's limitation because there's aluminum and steel ones. So that's kind of what they did, guys, for them here. Concrete on grade. So these are where all the place. Concrete below grade, yes. Steel, yes, for galvanized steel, no for non-galvanized aluminum. So there is steel. Can I put EMT underground? If it's steel, yes. But it has to be corrosion protected, though. Not a good conduit. Conductors, when installed, after complete raceway, you put your conductors. Number of fill conductors, chapter 9, right? As we all know. Corrosion condition, yes, but you have to have some corrosion protection, all of them. Can I put them in damp, dry and damp location? Yep, they're all rated for dry location and wet location, as a matter of fact. Expansion fittings, not needed except the PVC, if you remember that, Jeff, PVC. Exposed fittings and threaded. Which one of them have a threaded? Threaded, all of them. The first 2, rigid and intermediate, the rest no. Grounding, are they qualified as a grounding means? Yes, except the PVC. Can you guys read through these ones? A lot of information. Again, these are 4 articles in an EC code book, pulling information, put them side by side to compare them together. A lot of people who are familiar with the code, guys, know that. If you become a project manager, it's really, you don't have to memorize this, but the more you know about them, the better, especially this information. Any comments, any questions? Again, this is really not related. I don't know why we even have it in this book when it's, but it's good to have because we're doing a commercial. Okay, continue. Joints. Look at the length that they come. All of them come in 10. They have to be listed. Material, steel, galvanized, aluminum, PVC. The material. Rough edges have to be smooth before you pull the conductor. Support of the conduit. Yes, you have to support it. Securing them. Look at the securing them. Every 3 maximum from every box. Supporting intervals, typically 10 feet. There's some tables also for PVC. So if somebody to tell you how do you support a conduit and you don't know, a good answer, if it's metallic, it's 3 from every box, 10 in between. If it's PVC, 3, basically 3 in between, 3 from every box, with some tables they have to use. Look at the sizes. Now, can you guys see how PVC and rigid are superior? You can get these boards at the size of what? Can you guys see? 6. These are the 2 conduits out of, I think there is 1 or 2 more conduits in the code that you can get them in 6-inch. So they're superior. Threaded, all of them are 2 threaded or not, another 2 are not, of course. The weight, tell you about the weight. And wet location, this is my favorite. Can you install them in wet location? Yes for rigid, yes for intermediate, yes for PVC, yes for EMT. Just because you can't put them in wet location, guys, doesn't mean it's a good idea to put them in wet location. Now, Jeremy, when you come to Chad, when you go wet location, what's your conduit of choice? PVC. That's it. Though you can do rigid steel, galvanized rigid steel underground. EMT can be underground. It has to be protected by corrosion protection, though. Any question, guys, about these? Any questions? Here's how you support the PVC. 3 feet, PVC 3 feet intervals. And when it becomes big and fat and fluffy, then they allow you 5 feet. Okay, any question, guys? So you see how they did first. They took MC and AC cable, compare them. Then they took rigid, intermediate, PVC, and EMT, compared them together. And I can't emphasize, there's a lot of information, so please read them. Just be aware of them. I feel sorry for you because we've been using it for a long time. Now, the second comparison that they did here is flexible. Remember, we use rigid, metallic and non-metallic is one set. Then flexible, we use it to tie to equipment. And they listed 3 cables for flexibility, guys. Flexible metallic conduit, liquid tight flexible metallic conduit, and liquid tight flexible non-metallic conduit. So the only difference, the first 2 wet locations, the first one is dry location. Really, that's a major part. Same thing, bending radius, how many? Look at the large. They all come up to 4. You can put them 4 inches. Conductors were number 4 or larger. You have to protect for bushings. Almost all of them to protect for bushing. Look at these. Cable permitted inside them, yes. Concealed in walls, no problem. Concrete above grade, not FMC, but the other 2. So you can see where the damp. Here's my favorite. Can you use them in a corrosive environment? Yes, if protected. Yes, if protected, and yes, like those found around swimming pool and so forth. Damp and wet location, all of them. Exposed, yes, no problem. Bring it on. Grounding. This is the rules for the grounding. They start splitting here. But remember, we're engineers. When you have an EMT, when you have one of these, always pull an equipment grounding conductor, unless it's a fixture web. Fixture web, no. So here's where they tell you guys, like for example, the non-metallic, of course, you have to pull it because non-metallic. But here's where the 6 feet becomes a big deal as an equipment grounding conductor. For liquid tight flexible metallic conduit, they go based on the size and the overcome protection device. So there's a few other things. But typically, generally speaking, 6 inch or 6 feet or less fixture web, no problem. Other than that, other than fixture web is 6 feet, you have to pull an equipment grounding conductor. So, okay, so that's basically what they did in terms of flexibility. Grounding. Length. No limit in the length because they come differently listed. They have to be listed. Material, typically aluminum or steel for the metallic ones. Rough end, you have to smooth them. Supporting them, here's the support. All of them, can you guys see the support? 12, 4.5, 12, 4.5, 12, 4.5, typically, right? You can fish them though without supporting them from point A to point B as long as they are not broken. So if you have to support them, typically 12 inches from every box, guys, and 4.5 in between is your support, with some exception. Sizes, 1/2 inch all the way to 4. Temperature that they're rated for. The non-metallic is 60. Underground uses permitted. Wet location. Here's wet location. That's my favorite one. Is can I use them in wet location? No. And how about yes? And this one is yes. That's where the major difference between the 2 of them. Any comments, guys? Any questions? See, Jeff, how they put them side by side to compare them. Really nice table. Have you guys seen that before, putting them side by side? That's what I like about this chapter, is put these cables. If you go to the code, each one of these is, I don't know, 20, 30 pages talking about these, all this stuff that we summarize them. So it's really nice to know. Aaron, if you're not overwhelmed, then you're not with us. If you're overwhelmed, you are on the right, with the right group. I've been doing it for 22 years, and I still get confused between the conduits and the wires and the connectors that they use with them. There's just so much. There's so much. So you're gonna end up when you're in this industry, basically using, I would say, 20% of the methods in the code. You're lucky if you use 20% of what's described in the code. Really. So just don't. Okay. So there's a lot of. Absolutely. So that's what I mean, is that there's a lot of ways. As you use more of them, you get familiar with them. But I like the table because it really summarizes the whole deal here. Okay, the last thing that they had here, if you guys go to table 417, they have the SE cable. SE cable is special type of cable we use for service. I personally use it for services as we do, and for service conductors, service entrance conductors, and service conductors, and so forth. They have the following. Here's how these boys come: SE, SER, SEU, and USE. If you have a U in the name, it's rated for underground. That's kind of easy to remember. So here's the sizes. Here's the description that they use. Here's the installation. Can you guys see that they are used SE? It's used for X, HHW. A lot of conductors are in HHW in them. 600 volt or less, above ground, suitable for use where exposed to sun, because we bring it bends, not 5 times, not more than 5 times, not to exceed, not more than 5 times the radius. Ampacity for these, you typically you're going to go 75 or uses. Look, typically uses, guys, residential. Ampacity for them, it's going to be 75 or 60. Typically, if you put them inside inside the building, it's going to be 60, like NM cables. So these are for services, that coming overhead service conductors. Okay, so SE continues. What else? Bare conductor. Some of them, if he has bare conductor, guys, if SE typically, guys, 2 insulated conductor and 1 bare conductor with them. So if you're using them indoor, what do you need to do? You can't use the neutral uninsulated. So they're restricted to phase or hot to hot and a grounding conductor. Insulation temperature 75. So these are a couple of things. SER, they have I believe SER comes as an insulated. They have an insulated neutral with that. But if you're outdoor, I mean, not a big deal. SEU, the U stands for underground. So this is a boy that you can pull underground. Same deal. Use, but you can use it underground. Any comments, guys? Any questions? Any comments? Any questions? Same as USE, also permitted for underground direct burial, permitted to emerge above ground in meter boxes and so forth. So these are the cables, USE and SE and SER, the cables that you use service conductor to the building, typically, or coming overhead or underground if it's USE, and from building to building. We use them a lot in, as I said, in farming, Jeff, when we go from building to building, from pole to building 1, building 2, building 3, and so forth. Any comments, any questions, guys, about these wiring methods? So between 3 USE, SESR, SER, and we have 3 cables, 6, and conduits 4. That will give me 10, close to 12 wiring methods that they're going over. All the stuff that we went over, guys, is in chapter 3. I know I went fast on like the rigid and EMT. These are coming as we move into the commercial. As we move into the commercial, we start pulling an MC cable. You need to understand where MC cable is used, limitation of MC cable. Same thing EMT. Rigid, when we go industrial, we're going to be pulling rigid, threaded, and PVC Schedule 80. We talk about the limitation of these cables. So this is just the big picture. Any questions? Any comments? Any questions? So if you read it now, you understand it. You're halfway through, man. So that's all what I have for this chapter. I know it's big, guys, so I was hoping you would read it. And it's brutal. What is it? 44 questions on it? 49. Okay, that's all what I have. Any question, Aaron? No? Darren, my friend? All right.